Please continue.
All right. Thank you very much. Thanks for coming back. Now we have our S train, S test, Y train, Y test. Now, S train is what we'll be using to train our model. Now, this thing, I don't know if I might be finding it difficult to actually explain. It looks somehow confusing at first, but at the same time, it's not even confusing as well. Now, this is the way what we are trying to do is just as if we are taking a particular portion of our data. This is our X and Y. We have our dependent and independent variable. Train, we would use this one to train our model, our train, this S train and this Y train, these two. Then our S tests and Y tests we use to evaluate our model or to make prediction as well solver. So we have our S train, Y train, then we have the test size as 0.2. Now we use 0.2. Some will even use 0.1 because the data here is not even much, just 500 data. Why do we even need to use 20% of it for testing? Some will use 0.2. Why some will use 0.157? That's some will even use, but let's just stick to 0.2. Then random states. The random states, some always put 47, so you can change it. These are what if you keep with that, just I just parameters that we can just switch. So I'm just going to run this now. So let's look at our S train and see what's it then. So look at our S train. Look at this. Can you see the data has now just been randomly picked 47715 has just been randomly picked. It's not actually on one particular set. Then it actually was 404 row. So if you look at our S test now, S test just let's just S test. And you see this S test actually has was 102. This is the 20%, and this is the 80%. So we'll train our model on this. Now we have different type of machine learning models. It's not just one. We have so many. So I don't think they actually specify one particular. We should use one particular model. Can see they even say no model selection, no hyperparameter tuning, no, they didn't even want those ones. That means whatever your results, the results you are given, you don't need to go further to tweak anything. Briefly explain, okay, let's just use a simple machine learning model. So we have support vector machine, we have linear regression, we have random forest, we have decision tree. We don't even need to use XGBoost because those are even advanced machine learning model. So let's just use random forest or decision tree, anyone we are accommodate with. But let me just use two. So we'll look at it soon. Do they ask us to use one? So let's say from scaling dot some think forest or Jesus imports decision tree regression. So we're using this is a regression model. And also from scaling and that's let me just use SVM support vector machine, then imports SVR, support vector regressor. Those are the two models we'll be using. So the next thing to use is basically look for actually is instantiating all this model. So we will now say maybe it's decision tree equals to decision tree regressor. Then we actually look for SVR too. SVR, so vector regressor equals to SVR as well. So, and we are just trying to instantiate so we can start using those this variable name instead of calling the whole model itself. So just say this does fit. I mean, this is where the learning actually starts from. So we now apply to what's our S train and our what's Y train. So this is where the learning is now. And also SVR dot fits. Then same thing. S train. Then was Y train. So we're going to run the model. So this computer is going to be fast. What's just doing here? Just basically learning the pattern. Just learn the pattern and oh, how does this actually arrive to be this? That's what it's just doing. Some might take long, but this data is very small. But at the same time, you see So after you are done with this, so we need to evaluate the performance of our model. Always is okay, let's even make a prediction. For us to make a prediction, we have to look for we have to use this just predicts cloud predicting. We are predicting what's for what's S tests. So we'll just put this on was just say we can give the variable name called DT underscore pred. That means what the decision actually is predicting for us. And also we can actually say SVR underscore pred. Sorry, underscore pred equals to SVR does what predicts. It's also predicts what the S test for us too. So that means whatever this, let me explain something to us. You might be wondering that I passed S train and Y train here. I'm only passing S train because I'm expecting this one to predict this Y for me. This other part of Y. This second portion of Y. I'm going to predict this one. That's the essence of placing a model. We are applying this to predict this for us. So whatever I predict for, it should be stored in this variable here. So I'm going to run it now. So if you look at our DT, so this is what is actually predicted for us, this value. So you can actually start, you can actually see was in a data frame. So we have our S test as well. So our Y tests, these are Y tests. It look almost the same thing like that other one. So like the way we have this one. So because this is 102. Definitely I'm expecting 102 from here as well soon. So if you are not in that one, so you can just find the word the length. The length of this can you see is 102. It's going to produce almost the same. It should look similar. It should look similar. Now can we evaluate model? Now we have different metrics of actually evaluating machine learning model. So I'll be using, I think this specify any ones for us to use for a matrix. Let me check. Just machine learning awesome. Okay, based on your evaluation, they actually ask us to evaluate it. They ask us to evaluate our model. That means the matrix. All I need to do, that's to use from sklearn dot matrix. We have to import, we have the mean squared error, we have mean absolute error, we also have the mean squared error, we also have what R2 score. This R2 score is one we use for accuracy. So all I need to use here is just basically calling my R2 score, R2 score. Now this one is expecting what's Y true and Y pred. What is our Y true? Our Y true is what's Y tests. Then our Y pred actually was this one. Is that you use this? For instance, as a Y test. So when you run it, it's going to give you the percentage. So whatever the value is, you can just multiply by what's 100. So you have it's 1%. That means our decision tree. Yeah, that's our decision tree. Let you know the distribution. Now let's look at what our SVR is going to give us. Our SVR. So I'll just say how to score. How to score based on, let me just, okay, don't let me copy this. Y underscore tests. Then we have our SVR pred. Then let's multiply by us 100. So this one is giving us 27%. That means this one is not even, it's totally off points. Why this one is actually doing better? It's 1%. So you might actually want to even visualize. So we also have mean squared error. Now, for the mean squared error, it also takes almost the same parameter as well, sir, because it's actually checking where absolute error, actually the way of actually getting the error, actually maybe subtracting. For example, when the initial value was maybe 30, the real value was 30, then the model predicted it to be what? Maybe like 29. That's 29. What is the difference? It's actually 1. As you keep going, if you keep checking the difference between each and every of those values, wherever maybe the actual data, the actual value of a house was 13, and the model predicted it to be 0. That means the result is going to be what? 0. That means 30 minus 30 is going to be 0. That's how it keep checking. They now find what? The mean of all those error. So when you run it, it's actually having 2.7. Then we have to make sure this mean is very, very low. The lower the mean, that means the better the model. The higher the accuracy score, the better the model thing. So that means this mean has to be very, very low. And also the mean squared error to have to be very, very low. So I have the mean squared error as well. So and just we are still checking for decision tree. We already know that support vector machine is going towards consistent is 13 because this is square of all the whole error. This is still fine. Then for the other one, a support vector machine. How we need to do, you have to look for support vector machine as well. So how you need to do, I have to put this value here because it's always taking the x true, sorry, the y true and the y pred. Oh, sorry, it's still there. So we have 4. You can see this one is still lower than this. That means this 4. How we should to improve the hyperparameter tuning. For some other things we can do, like scaling it. We can scale the data. Even if you don't want to scale it as well soon, we can actually remove some outliers. Because we even noticed that we even have some outliers in our data. We didn't bother to even remove those things because this allows us to just scale through the surface of machine learning. It doesn't also know outlier. And moreover, because our data is not actually more, that's the reason why. Now we have about 10,000, 100,000 of data. I'm very, very sure we have to remove all those outliers. We're going to scale it as well soon. To put it on a standard scale. So that's about that. Now, based on this now, we now have to start writing based on your evaluation, discuss some potential improvements you could make on your model. Now, that's some of the potential improvements you could make. Number one is that we have so many improvements we could make on this model. Number one, you can just say maybe using another different algorithm or scaling the data. The way we handle the missing value, we use median, we use mean. Why don't we use another value? Why don't we use something else? Why don't we don't necessarily need to use mean for all the whole features, but we will just use mean of everything. Why don't we look at, oh, we should look at the particular features, look at the attributes. Based on it, you should determine, okay, if it is mean or median, or we are going to just generate a value by ourselves, fill it up. Why don't we look at them one after the other? Also, you only use audio features. Does it mean that audio features might be important? Why don't we just take this one off point? So that will call feature engineering or feature importance. Why don't we look at some of the features that are very, very important to us and work with the important features rather than using audio features on a go? Audio features might not really be important. For example, they're telling us to describe between maybe the how would I put it? Two different things. Or maybe a house and a shop. You are trying to predict if this is actually a house or a shop. You know, somebody now mentioning cement. Cement is not an important feature because cement you always definitely use cement there. So there's some features that are not really important. Yeah. So there's ways of actually checking those things by removing feature important. Like all this, and I don't know if it's going to be very important for what we are doing. Don't know. But we just use everything together. That's some of the way we could improve on this model based on our evaluation. Another thing also we can also do, also maybe handling, I've talked about missing value. Now also overfitting. We have to make sure our data is not actually overfitting. In fact, this model is not actually overfitting, sir, because at least it has 21%. Now we can actually make a prediction by ourselves, sir. I don't make a prediction by ourselves. Based on this data, we can actually make a prediction, which you can actually into the but really look at this prediction. Now you might also visualize it. See what we used to do. What we need to I can just say like our PLT, but and just look for the histogram. Sorry, histogram of we have our histogram will always take our X and Y. So we can just say, for example, our Y tests subtracted from what's our maybe SV. Let's use that decision DT trade. Let's look at the distribution. Can you see? That's the distribution of us. What am I trying to do here? I'm just trying to subtract the what the model predicted for us from the actual value. Yes, from the actual value. Because the actual value, this is the DC spread. This is the actual value. Finally puts into a data frame. Okay, let's just put inside a data frame and compare it together. So we can be able to see it on a different form. We can just see, I will just see really dots a data frame, a frame of this one. Then maybe the column and let's just say decision tree predicted. So let's just put what we have in there. So this is decision tree predicted. I'm just going to call it what dicen. Dicen. No, dicen. Let's just call it dicen underscore. So let's call it dicen underscore. Then our original y tests. Our y test. No, our y also is in form of series. So I have to convert it back to this data frame as well. So PD does data frame. We're going to take our S tests. Then we have our column as well. So let's just call this original value. Let's call this let's call it y test. When are we going to have underscore? Remember, this one is having underscore. So if you look at this one now, oh, sorry, there's something wrong here. Yeah, thank God I have to just change the value. Y tests. Seven. So why is it not 7? How to put the data frame? That's a data frame. Then y underscore test. Yes, column equals let's use a column first because why it's not coming out. Okay, I think this is what the issue is all about. What I'm going to do, we have the original y, our original y tests. We have our original y test. This is our original y test here. The original y test. Let me see pd dot series. Yes, pd dots. Let's just convert it back to series first. Let's test. So it's not form of series dots. Though we are done with our work, I just want to so we can see the comparison. That's what I'm just trying to do. So let's try rerun this. If it's not still open, then let's just convert this one back to us a numpy array. An np plus array of what's y underscore test. Yeah, so with this now. So I'm just going to call it was y underscore test. So it's going to work now. So that's call this one our original. So when you now call our addition now, so you can see we have the original x. So we can just say ed dots. We can just use our concat method here. Then we use the original the Y tests. Then we also have the words the DT underscore. Then definitely as is always was that I want. So you can see this is predicted. This is the original one. This is what is predicted for us. That means when their original value was actually 23 points. Let's look at the first thing so we can see it very well. When it was actually 23, the model was actually predicting towards 25%. When it's actually 32.4, it was predicting to be 32.0, which is, you can see that's almost like 0.2 difference. Why some words? It's actually more than what we actually have there. When it was 13, so say no, it was 15. These are some of the errors we're looking at. So we have to look for a way of actually minimizing this error. Those are some of the words evaluation. Because based on your evaluation, discuss some potential improvements. So that's what we are going to discuss in our so that's the end of the stuff. Do you have any question or any observation or any suggestion for me? For its comments.
Please, is there any question? Are you done with all the questions?
Yeah, that's all the questions.
Show the questions. Let me see the questions. Display the question.
These are questions.
Display it. Okay, you are
I've
done
displayed
with
it.
those two questions, right? That is the first
Those are two.
dot, second dot. Okay. Any question from audience? You are free to unmute yourself and ask questions if there is any, or if there is anything you observation,
Or suggestion.
projections, addition, or subtraction.
Hello, sir.
Hello, sir. Hello, you're
Can you hear
welcome.
me, sir?
Yeah, we can hear you.
Hello.
Uh, the first place, I want to appreciate you very much as the facilitator of Team R. I thank you to tell you that I have learned a lot in this tutorial tonight.
All
And
right.
I believe between tonight and tomorrow, I'll be able to, and not only me, well, in addition to whatever they know earlier.
Okay.
Having said that, so I want someone ask this afternoon on the group with respect to exporting the Jupyter notebook.
Okay.
Actually, I had a link earlier. I tried it also, which I also gave it to him. But I discovered at the end of the day, my tool was not also working.
Okay.
Do a little research about it.
You mean to
I
convert
discovered
this
that
to convert this Jupyter book to convert this to PDF file?
Hello, sir.
You mean to convert this PDF to PDF file?
Exactly. Yes. It's more like a
No.
Pandoc and how to get
Now,
it
please
done. Thank you very much, sir.
convert this to PDF file.
Now, if you want to convert this file to PDF file, all you need to do
Yes,
is
sir.
you go to your file. Now, if you click on download as PDF. Though it might not work. It might not work for maybe just anyhow laptop, or if you have not in, there are some things you need
Yes.
to install. But if I run it on my own, it's going to work. For some of you guys who might show maybe trying to run and it's not working, it might not even work, honestly speaking, because there are some Chrome extension that you need to install on beforehand. But what people always do, you can see if I open it now, it will be very, very different from the one we all know. You can see it's the noise to take, the noise to jump. It knows to jump. If you follow the normal, regular way, actually, can you see? There's a difference because there's some extension you need to install on this laptop. Although Jupyter Notebook actually remove some, I see it's bringing out some migrational plan also. But what we always do is that you just click on Control and P, Control P.
Yes, as if you wanted to print.
Can you see?
So,
So as if you want to print it.
so from there you convert it
You want to
to
print.
PDF from the
So
printing.
then
Okay,
you now
okay.
change save as PDF, then you now save it. So you just do Control P or Command and P if you're using Mac. Command and P. But if you're using Windows, Control P. You're going to save it as PDF.
All right.
Sometimes,
Thank you very much. I just
hello. Sometimes when you press Control P, it might break you as if you want to print. But you want to go to that printing column and change it to save as PDF.
As PDF, yes, thank you. All you just need to change the option, destination to print.
Just
Save
check
it as PDF, I mean.
click that place, click it.
Then
The option
all
will show. Click
you need to
that
show
save as PDF there. Click that
so you
save
can
as
see this
PDF.
save as
Yes. See
this
more
is save
options.
as
No, click on more options.
more
Click
option.
on,
There's going to take me to my
hello. Click on more options here. Let
hello.
us. So when you click on more options there, likely you see more options like print the file, something like that. Or what you need is save as PDF.
Just save as.
That is all.
Then you now click on save. And when you click on save, then it's going to. So it's the PDF you need to upload on the Google Classroom, and not
one question
the
from Madam Monilisa Dike. She's asking that how can we save it as a Word? Okay, click on file. She's asking for the how can we save it as Word format.
So I don't think it's actually possible to save it as Word.
No, it's possible. Click on that. No, not that place. Not that place. Click on that file. Now go to oh, I don't think your system has it. Okay, you have less than 10 minutes. About 10 minutes. In my system, it has. Okay, go to preview. Go to preview. Click on preview. Let's see what happened preview.
I'm only having print preview.
Okay, print preview. That means you don't have some options.
But the only thing I think you can do here
Let's see this
is
preview.
Is that you can save it as PDF, then convert it to Word. But I think from this
my own system has a place where I do this.
Please, I want to ask a question, please.
Please go ahead, ask a question.
I want to know if this Jupyter Lab you're working it from Anaconda or it's just you downloaded it separately.
No, see, before I started the class, I actually said something. I will not be using Jupyter Lab. Jupyter Lab is the one used in the class. We have different platforms. I'm using Jupyter Notebook. Some people might even use Google Colab. I'm using Jupyter, but everything here will still work fine. The same way.
Okay, but you downloaded the Jupyter Notebook on its own.
No, Anaconda itself actually has so many packages. You have Jupyter Lab, we have Jupyter Notebook, we have Spider, we have some other platform as well. So even VS Code, you can run. They're just different platforms you are running it.
Well, my question is, did you just download Jupyter? It just downloaded Jupyter Notebook on its own.
I downloaded
not like a work.
I downloaded Anaconda.
Okay, you do.
I downloaded Anaconda. Let me show you something. When I click on this Anaconda, for instance, Anaconda Navigator. When you click on you download Anaconda, you're going to see everything.
Okay, I understand. I just wanted to know.
So that's what I did.
I know that you can get all of it from Anaconda. That's what I wanted to know.
From Anaconda, actually goes this from.
Okay. Yeah. Thank you, sir.
Hello, Dr. Tim.
Yes, I'm with you.
Yeah, please, can we have a copy of this tutorial?
Yes, I'm going to share in the group.
Okay, thank you.
Yes.
Okay, so this Anaconda that you
this is the Anaconda. So it has Jupyter Notebook and Jupyter Lab. You can see Jupyter Lab is there, but I just decided to use Jupyter Notebook. This is the one the instructor used in the class for Jupyter Lab.
Okay, sir.
Jupyter Notebook as well. So.
Thank you.
I'm coming. Just give me 1 minute. Give me 1 minute. I'm trying to do something so that I can quickly solve. before our 10 minutes now can lapse. Now we lapse.
Hello.
Hello. We are coming.
Yes, sir. Okay. All right. Can I ask questions, sir?
Yeah, ask your question.
These questions are
Okay. Please, please, can you go to where you plot box plots? I want to ask question there, sir.
okay. I'm with you. All of the time. This
All right. Okay. Now, I thought we are plotting the box plots for all the variable under consideration.
all the
Hello?
all the box plots.
Yes, I thought the box plot will be plotted for all the variable, not only the one, not only for the,
Median housing,
not
right?
only for one. Yes.
This okay. We can actually do something like this as well. So PLC dots box plus. Just need to just change the variable name. Now I can just decide to just pick, for example, let me pick this one here as my x. That's my x should be equals to maybe this. Then you might actually want to plot it based on your y. I can just say my y is actually towards this one in particular. Then you can say maybe the data is still decided on what house. X and y. Okay, tell me why is not actually needed for this data. Okay, let's just change. I can see change. Let's just change this x. So our y itself. Let me just change. So what's my house? My house itself. And this is what you are talking about, that maybe you are trying to plot for all the odds, all the variables. Is this what you're talking about?
Yes, this is what I mean.
So, but we can still pick it one after the other. Anyhow, we want to do it. We can pick it one. We can even pick two together. So some even do something like this. Just pick maybe two different columns. For example, we have the hand media and the index. So just pick this one and also just pick another one as well. So, and pick this one here and run currency just only it. Then they can just use maybe PLC, that's legend as well. So, and run something like this. The end is not actually coming out, but you can actually, because of time, I don't want to start editing, but so you can decide to skip adding 2, adding 3, adding 4, adding more to it. But if you don't still want to leave it like the way you mentioned, just only house like this, it will still work as well. So that means now start seeing one after the other. Which I might not really be a standard trend. Yeah, you can just pick the important one out of it, then just process. Should you give my
Hello,
points?
sir.
Hello, we are with you.
All right. In addition to the last speaker announcer, I think what I want to ask, so we should discuss an initial insight again about the relationship between the features and the housing. It's a question anyway. With coming of correlation analysis, I think will I be able to tell more within my target?
We can come up with different backgrounds, different things we think we know we can do. All of us cannot do the same question, cannot do the same thing. So when you think you will add something to what he has just discussed now, you are free to do that. There's no penalty for that. I think so.
No, it's not a direct something. Everybody has different. We have
But
different
also, it's not a
features.
direct
You can,
something. Everybody will have
no, they didn't
different
have
things to say.
everybody have different one. You can say to call this one your X and call this one your Y. The chat might look another different, and you write your own insight based on it. So you can pick any features. We have different features
So
here.
that means it is not compulsory for you to say your Y is V. So you can choose your Y to be another thing. So you are the one to define your Y. Is that also? Bilau.
That's it. Yes, that's just
So
it.
somebody
That's
can
just
say my Y now, my target variable now is probably Indus. Indus, that's my target variable. And you choose the rest as your future variables. So that does it. Any question, please? I think we have about
Yes, sir. My last
1 minute to go.
hello.
Hello.
Hello, sir.
Welcome.
Yes, my last hello, sir.
We are with you.
Hello, I'm with you.
Hello.
I'm with you.
My last question here is, okay. In the last question is they say based on your evaluation, the score you could make in your model. So that question confused me in the last. I don't know how I'll make it.
Potential
How-
improvements. Is it this one? Based on your evaluation, discuss potential improvement you could make on your model. Now, I already mentioned it
Yeah.
already. There are some potential improvement we could make. Number one could be what? Scaling. We can try to scale our data. What are the best way we can try